Example 13.5. A particle moves at its displacement s meters from a point O after t seconds is given by s equals 8 cos 5t plus 15 sin 5t. We want to prove that the particle will perform simple harmonic motion. Now the displacement s is given by 8 cos 5t plus 15 sin 5t. So if we differentiate displacement, it gives velocity. So velocity is the sdt. Now if we differentiate 8 cos 5t, the 5 multiplies with the 8 to give 40, and when you differentiate a cos 5t, it gives a minus sin 5t. So this gives minus 40 sin 5t. Next of all, if you differentiate 15 sin 5t, the 5 multiplies with the 15 to give a 75, and when you differentiate the sin 5t, it becomes a cos 5t. So velocity is minus 40 sin 5t plus 75 cos 5t. Acceleration then is the rate of change of velocity. So we need to differentiate this again. The 5 is going to multiply with the minus 40 to give minus 200. And when you differentiate sin 5t, it becomes a cos 5t. Next of all, the 5 is going to multiply with the 75 to give 375. And when you differentiate cos 5t, it becomes a minus sin 5t. So this means the acceleration A is minus 200 cos 5t minus 75 sin 5t. Now omega is 5, so omega squared will be 25. So if we factorize it minus 25 out of both of these terms, the acceleration is going to be minus 25 on 8 cos 5t plus 15 sin 5t. And this is what we started with. So this means A equals minus 25 times s. So this means the particle does execute simple harmonic motion with omega equals 5. So A does equal minus omega squared times s. Part 2 then, we want to find the periodic time. So t equals 2 pi over omega. So t is just going to be 2 pi over 5 seconds. Next of all, we want to find the amplitude. Now the displacement s is 8 cos 5t plus 15 sin 5t. Using Pythagoras' theorem, the amplitude A is going to be the square root of the 8 squared plus the 15 squared. 8 squared is 64, 15 squared is 25. When you add these together, this gives 289, and the square root of 289 is 17. So the amplitude A is 17 meters. Next of all, we want to find when s equals 0 for the first time. So s equals 8 cos 5t plus 15 sin 5t. If we put in when s is 0, 0 equals 8 cos 5t plus 15 sin 5t. Now, if we bring the plus 15 sin 5t across, it becomes a minus 15 sin 5t is 8 cos 5t. Then we're going to divide both sides by cos of 5t. And what happens then on the left-hand side, you get minus 15 tan 5t. On the right-hand side, you just get 8. The cos 5t's cancel. So minus 15 tan 5t equals 8. So this means then the tan of 5t just equals minus 8 over 15. Now we're going to get the inverse tan of minus 8 over 15. And when we do that, we need to know in which quadrants tan is negative. So tan is positive in the first and the third quadrant, so it's negative in the second and the fourth quadrant. Now this means that if we want to get the angle in the first quadrant, if you get the inverse tan of a plus 8 over 15, that gives you the reference angle. That's the angle in the first quadrant. So the angle in the second quadrant then would be pi minus that value. So this means 5t is going to be the inverse tan of minus 8 over 15. Now if you get the inverse tan of plus 8 over 15 and subtract that answer from pi, that's going to give us this answer in the second quadrant. So this is going to be pi minus 0.489957. So using your calculator, if you get pi minus 0.489957, that's what 5t is. And then dividing by 5, this means t works out as 0.53 seconds.